Hi everyone, this is Tutor Marife MCP. I create math tutorial videos that could serve as your supplemental learning resources. In this video, you will learn how to simplify these 5 given expressions using the index laws or the rules of exponents. Let's start with the first given expression. Our first expression is negative 2a raised to 10b raised to 4c raised to 6 all over 8a cubed b raised to 6c raised to 8. How do we simplify this expression? We are going to apply the quotient rule and the negative exponent rule. The quotient rule says that to divide exponential terms with the same base, keep the common base and subtract their exponents. The negative exponent rule says that to change a negative exponent to a positive exponent, flip the exponential term into its reciprocal. Okay, so let's start. For our first step, let's write the constant terms together and write the exponential terms with the same base together. This is also equal to negative 2 divided by 8 times a raised to 10 divided by a cubed times b raised to 4 divided by b raised to 6 times c raised to 6 divided by c raised to 8. If the number of negative signs is odd, our answer should be negative. Reduce the fraction to its lowest term, divide both the numerator and the denominator by their greatest common factor. The GCF of 2 and 8 is 2. So the lowest term of 2 over 8 is 1 over 4. Let's apply the quotient rule 3 times. For this one, keep the common base a and subtract the exponents 10 and 3. For this one, keep the common base b and subtract the exponents 4 and 6. And for this one, keep the common base c and subtract the exponents 6 and 8. Evaluate the difference between the exponents. 10 minus 3 equals 7. 4 minus 6 equals negative 2. 6 minus 8 equals negative 2. Any number has an invisible denominator of 1. When simplifying expressions, all the exponents in the final answer should be positive. We have 2 exponential terms with negative exponents. Let's apply the negative exponent rule to make the exponents positive. Okay, so by the negative exponent rule, we swap the numerator and the denominator to change the negative exponent to a positive exponent. B raised to negative 2 over 1 is equal to 1 over b squared by application of the negative exponent rule. C raised to negative 2 over 1 is equal to 1 over c squared by application of the negative exponent rule. Let's copy this. Express our final answer as a single fraction, multiply all the numerators and multiply all the denominators. Multiplying all the numerators, we get a raised to 7. Multiplying all the denominators, we get 4b squared c squared. The sign of the answer is negative. Our final answer for the first expression is negative a raised to 7 over 4b squared c squared. Let's simplify the second given expression. We have 2x raised to 4y raised to 7z squared enclosed with parenthesis raised to 3. How do we simplify this expression? We are going to apply the power of a product rule and the power to power rule. The power of a product rule tells us that when we have more than one factors being multiplied together and raised to a power, it is equal to the product of each factor raised to the same power. The power to power rule tells us that when an exponent is raised to another exponent, we keep the same base and combine the exponents into one by multiplying them together. Okay? So for our first step, let's apply the power of a product rule. We have 1, 2, 3, 4 factors being multiplied together and raised to 3. By application of the power of a product rule, let's raise each of the 4 factors to exponent 3. So our first factor is 2. Raise it to 3. Our second factor is x raised to 4. Raise it to 3. Our third factor is y raised to 7. Raise it to 3. And our fourth factor is z squared. Raise it to 3. By application of power to power rule, let's combine the exponents into 1 by multiplying them together. For this one, evaluate 2 cubed. 2 cubed means 2 times 2 times 2, it's equal to 8. Multiply the exponents. 4 times 3 is equal to 12. 7 times 3 equals 21. 2 times 3 equals 6. In simplest form, the second expression is 8x raised to 12, y raised to 21, z raised to 6. This is the final answer. Let's simplify the third given expression. We have negative 3 enclosed with parentheses raised to negative 3. How do we simplify this expression? Obviously, we are going to apply the negative exponent rule because of the given negative exponent. Once again, the negative exponent rule tells us that to change a negative exponent to a positive exponent, we flip the exponential term to its reciprocal. By flipping, we mean by swapping the numerator and the denominator. Okay? So any number has an invisible denominator of 1. We can rewrite the given expression as negative 3 raised to negative 3 over 1. Let's change the negative exponent to a positive exponent by interchanging the numerator and the denominator. 1 over negative 3 cubed. The exponent becomes positive. Then, evaluate negative 3 cubed. In expanded form, negative 3 cubed means negative 3 times negative 3 times negative 3. We have an odd number of negative signs. Therefore, the value of negative 3 cubed must be negative. And it's equal to negative 1 over 27. This is the simplest form of the third given expression. Let's simplify the fourth given expression. We have s raised to negative 2 raised to 3 times t raised to 5 all over t raised to negative 3. How do we simplify this expression? We are going to apply 3 exponent rules, namely power to power rule, quotient rule, and negative exponent rule. For our first step, let's rewrite the given expression by writing the exponential terms with the same base together. This is equal to s raised to negative 2 raised to 3 times t raised to 5 divided by t raised to negative 3. For this part, let's apply the power to power rule. Once again, the power to power rule tells us that to raise a power to another power, we keep the same base and combine the exponents into 1 by multiplying them together. Okay? So we keep s and multiply the exponents. Negative 2 times 3 is equal to negative 6. For this part, let's apply the quotient rule. The quotient rule tells us that to divide exponential terms with the same base, we keep the common base and subtract their exponents. The common base is t. The exponents are 5 and negative 3. Apply the negative exponent rule to change the negative exponent into a positive exponent. Any number has an invisible denominator of 1. To change negative 6 into positive 6, interchange the numerator and the denominator. S raised to negative 6 over 1 is equal to 1 over S raised to 6 by application of the negative exponent rule. Evaluate the difference. 5 minus negative 3 is the same as 5 plus 3. And 5 plus 3 is equal to 8. So t raised to 5 minus negative 3 is equal to t raised to 8. Again, any number has an invisible denominator of 1. Express the final answer as a single fraction, multiply the numerators and multiply the denominators. In simplest form, the fourth given expression is equal to t raised to 8 over s raised to 6. This is the final answer. Let's simplify the last given expression. We have negative 3x plus 7 quantity raised to 0 all over 2 raised to negative 3. How do we simplify this? We are going to apply the zero exponent rule and the negative exponent rule. The zero exponent rule tells us that any number, any term, any expression, any group raised to 0 is always equal to 1. So for our first step, we can simplify the numerator of the given expression by application of the zero exponent rule. This group raised to 0 is always equal to 1. So the given expression becomes 1 over 2 raised to negative 3. To simplify further, let's use the negative exponent rule. To change the negative exponent into a positive exponent, let's flip the exponential term into its reciprocal. Interchange the numerator and the denominator. We now have 2 raised to positive 3 over 1, or omit 1. We have 2 cubed, or evaluate 2 cubed, it's equal to 8. This is the simplest form of the last expression. That's it. If you have any questions, you want further clarification, or you want to give a feedback on this video, feel free to post your comments. Again, this is Tutor Marife MCP. I thank you for taking the time to watch my video.